Okay, we have reached lesson 4 for linear inequalities. We're looking at multi-step inequalities, so we're building off of the work we've done in lesson 3. You're going to need to also remember your work that we've done through chapters 8, solving equations. Okay, they're not going to be quite as crazy as the equations you had in chapter 8, but along the same lines. So these 3 are review questions for you. I'm going to give you the solution. I want you to, I want to see your work that you have, how you found the solution, not just your answer. And then I want to see you checking 2 boundary points. So verifying one value that is within your boundary and should give you a correct solution, and then one value that should be outside of your boundary and will give you an incorrect solution. Okay, so I'm looking for your work for these 3. These are just like from lesson 3, so if you don't know how to do those ones on your own, please make sure you watch lesson 3 again or come see me in tutorials. All right, here's where things start to get a little crazier. So again, we have 2-step inequalities or multiple step inequalities, and we are looking at isolating the variable and keeping in mind that if we divide or multiply our inequality by a negative, that we are flipping the sign of the inequality. So looking at this first example, I need to deal with the plus 3 first. We're going to minus 3 on both sides of the inequality. So then we get x plus 4 must be greater than 5. We subtracted, but we got some creepers out here. Jill is creeping. Calamity is creeping. Oh, sorry. Shout out to the girls that are annoying me on a Thursday night when I want to go home, but instead I'm staying late after school so that they can do stuff instead of record your lessons. So if your lesson is now 20 minutes long, now you know why. Are you leaving? Okay, bye, girls. All right, now we'll have some peace and quiet. Okay, so x divided by 4 must be greater than 5. We're going to multiply both sides by 4. So now we have x must be greater than 20 as our solution. And this says we need to show our solution algebraically and graphically. So how that algebraically, graphically means on a number line. So put my boundary point, put a couple other values on there, and so the inequality is an open circle because it's x is greater than, and so if x is going to be greater than 20, the line has to go, or the arrow has to go to the right. So we're looking for values that are bigger than 20 to satisfy this inequality. So if x, let's go, I know that I have to divide by 4, so I'm going to be strategic. I'm going to pick x of 24. So then 24 divided by 4 plus 3 should be bigger than 8. So 6 plus 3 should be bigger than 8, and 9 is bigger than 8. So we're good. Let's check a value that should not work. So let's go x equals 16. Again, I'm being strategic about this. I'm thinking about numbers that I could divide by 4 nicely. So 16 divided by 4 plus 3 should be bigger than 8. 4 plus 3 should be bigger than 8. 7 is bigger than 8. No, it's not. So we've got a good boundary point. So our inequality solution of x is greater than 20 works. There's interruptions all over the place here. Okay, so that's letter A. Letter B. No fractions this time, so that's good. But we do have more than one variable, or one variable, but more than one time. So we have like terms that we need to group. Now, I always want to group my variable first in such a way that I can make it positive if possible. So if I move the 3x, I'm going to be adding 3x to both sides, so then I'll have positive 8x. That's good. If I moved the 5x, I would have to subtract 5x from both sides, and then I would have a negative 8x on the left. And then we have to worry about negative x's, and so we're going to try to keep x positive if possible. So we're going to add 3x. So then we get negative 10 less than or equal to 8x plus 38. Okay, so now we group the x's, now we need to group the constants. Minus 38, minus 38. So negative 48 must be less than or equal to 8x. Divide both sides by 8. We get negative 6 must be less than or equal to x. So now we need to show this on a graph. So a number line. Boundary point is negative 6. So I'm going to put that in the middle and then a couple other points around it. Keep in mind when you're in the negatives, your negative digits are increasing to the left as the value decreases. It's going to be a colored in dot at negative 6 because it is equal to, and x must be greater than negative 6, so our arrow is going to the right. And again, we could pick some values to check if our work is right. This question doesn't tell us to check, so we won't check this one, but we will check some later ones. Okay, again, things are starting to look a little crazy. So when we look at letter A, we have a coefficient outside of a bracket, which means we either need to rainbow or we need to divide everything by negative 2. I notice that 10 and 18 are on the other side, so they will divide nicely by negative 2, so I'm going to divide everything by negative 2. Because I'm dividing by negative, the inequality sign is going to flip. So on the left-hand side, I get left with x plus 3. On the right-hand side, I get left with negative 5x minus 9. Now, if dividing by negative 2 seems really, really strange to you and you would rather rainbow, go for it. We should get to the same solution. So again, we're going to group like terms. I notice that there's a negative 5x on the right, so if I move it to the left, it will become positive. So let's do that. So we get 1x plus 5x, we get 6x plus 3 is greater than or equal to negative 9. I'm going to subtract the 3 on both sides. So then I get 6x is greater than or equal to negative 12. Divide both sides by positive 6, so we do not flip the inequality sign, and x must be greater than or equal to negative 2. Okay, now I don't know about how big you write, but on my paper, when I wrote this in, I was running out of room to do checks. So we're just going to do a quick check. Every time we see an x, we're going to replace it with a negative 2. Okay, and so in this case, we're just substituting one value to see if we solve properly. And we should get the same number on both sides, just like when we solved an equation. It may or may not satisfy the inequality. In this case, because we have an equal sign, it will satisfy the inequality. And keeping in mind BEDMAS, solving things in the correct order, we are going to do brackets first, so then we get negative 2 times positive 1 is less than or equal to negative 20 plus 18. Negative 2 times positive 1 is negative 2, and that's less than or equal to negative 2. So we're good. Our solution is correct. We could verify using two values like we've been doing to show if the inequality sign is in the correct order. We're just seeing if we've found the correct boundary point right now. Okay. Question B, 4x plus 11 must be greater than 35. Hopefully these ones are starting to seem really easy to you now. So we're going to deal with the constants first by grouping them. So minus 11 on both sides, so 4x must be greater than 24. Divide both sides by positive 4, x must be greater than 6. So then we're going to verify, we'll pick two values. Let's say, well, we need x that's bigger than 6, so let's say 7. So 4 times 7 plus 11 must be greater than 35. 7 times 4 is 28, plus 11 must be greater than 35. 39 is greater than 35. Let's pick a value that's less, so let's pick 0. 0 is less than 6. 4 times 0 plus 11 must be greater than 35. 4 times 0 is 0, so 11 must be greater than 35. It is not. So it looks like we have a good boundary point and a good inequality. All right, letter C. So again, in letter C, we have x's on both sides of the inequality, and we have constants on both sides of the inequality. So we need to group our variables together to start with. And so I look to the side that is going to make the variable positive, and that's by moving everything to the right. So I'm going to add 2x to both sides. So 5 must be greater than 12x plus 29. Now I can group my constants. Minus 29, minus 29, negative 24 must be greater than 12x. Divide both sides by positive 12, so the inequality sign does not switch. So negative 2 must be greater than x. Okay, again, we could pick some values to verify. I'm not going to substitute that one in, and you should be able to do that. Okay. Letter C you would do quite similarly to letter B on the last page. All right, our last example. So again, we are looking at a coefficient outside of a bracket. So we're either going to rainbow, or we're going to divide both sides by 4. When I look at the other side, I have 5x and I have negative 12. The negative 12 will divide nicely by 4, but the 5x will not. So to make our lives nice and easy, we'll just rainbow. We could go 5 divided by 4 and put it as a decimal, but I'm going to try to keep whole numbers and show you a different method this time. So 4x minus 8 is greater than or equal to 5x minus 12. Again, we're going to group like terms. 4x is positive and the 5x is positive, but 5x is bigger. So I'm going to move the 4x over so that way it stays positive. So negative 8 is greater than or equal to 1x minus 12. You can keep the 1 in front of the x, but you don't have to. We're going to plus 12 on both sides. So positive 4 is greater than or equal to x. Okay, and again, we would verify by substituting and following BEDMAS. So that's your lesson 4. I have advised you that you will have a quiz next class. On your quiz will be 2 of the questions from this lesson. It might be these 2. It might be these 2. It won't be any of these, but it might be these. Literally, I'm going to give you the exact same questions that are in your notes. So please make sure you know them and are ready to solve them and check them using 2 values to substitute. Okay, that's it for your lesson 4.